Hey everybody, back with another video, and today's live event is going to be all about blueprints. We're going to go through the history of blueprints. We're going to talk briefly about electrical prints and plumbing prints and HVAC prints, a couple different types of prints and how prints can lead into diagrams and things of that sort. With us today on the show, like many times before, is our good buddy Joe. Joe's coming with us, and he's got a lot to offer. Joe's going to kick us off with the history. Oh, look at that. Technical difficulties left and right. This is funny. Okay. There. Okay. Yeah. All right, Joe. You're snickering, aren't you?
Yeah.
All right. So it's yours.
All right. Thank you. Hey guys, what's going on? Hey, just a quick little update. So we did this a few minutes ago, and for those of you that joined us a few moments ago, we had some issues. Guy and I are about 1,000 miles apart, and our audio link just completely went dead. So it's hard to do a interview show with no audio. So anyways, we're back online now, and we're good, and we'll just hope this all works out. So anyways, just to cover what we did last time was we had this issue with we had this this discussion about blueprints and how the blueprints work. So I'm going to just do a quick little overview for those of you who have already seen this. I apologize, but we'll do a quick little coverage. So anyways, how blueprints are what? Okay, let's back up. What blueprints are a copy. Back before the 1800s, there was a problem with the engineer, the person that actually created the drawings, was always either having to bring a master copy or have someone hand copy his drawings to another piece of paper. That second piece of paper would be the copy. The copy would allow you to have workers to install your work. So what's, that it got expensive, that got time consuming. I mean, by the time someone actually sits there and copies a drawing for a print, of course, back in the 1800s, you're not talking about anything super elaborate. Even though a lot of main structures, we had quite a few large structures that were built, but these were all hand-drawn copies. So back in the 1800s, early 1800s, a process came about called blueprinting. And what this is two chemicals, ammonium iron citrate and potassium ferrocyanide. These two chemicals put together create something called blue ferronide. I'm probably butchering that whole up. It's but the Persian blue is the term that when those two are combined. So what this does is it creates a solution that is photosensitive, meaning that when light hits it, it reacts. So by using this process, what has happened was when light is exposed to this chemical, it turns blue. So what we're doing here to create copies is we're taking a master copy and making a secondary copy. So by doing this, all right. So let's say we took this this master copy, and we're gonna have the engineer draw it on a translucent piece of paper. Translucent being light can go through it. So either like a tracing paper or a cloth or something like that. That would be translucent. As the master drawing would be then set aside, the copy paper would be coated with this Persian blue solution and allowed to dry. Once it's dried, in a dark room, obviously, and then when it was applied to light, it would turn blue. So what they would do is they would take the original drawing from the engineer on the translucent paper. They would put it on top of the paper covered in the solution, and they would shine a bright light through the papers. And anything that was not covered with a marking from the engineer, was not covered from the engineer as far as marker or pencil drawings, would turn blue. Anything that actually had a marking on it, like a pen drawing or a stencil or whatever the engineer put on the paper, would block out the light and would remain white. So a lot of these older pictures or blueprints would have a blue background with a white front. And this made it a lot cheaper and easier for many, many years to have, copies made. So you could have many of these solution or a large amount of solution made up, large amount of paper or copies created, and then one master copy, which would make all the additional copies. So once this was established, this process, it became very easy to have installers or people that actually doing the work to follow what the engineer had designed remotely, allowing the engineer to remain in his office and doing what he does best, his drawing and engineering, and then the installer is doing their part. Hopefully, with this new technology, it became faster, easier, cheaper, and a lot more efficient to have many workers follow the same drawings. So what these drawings are is a description or a instructions on how to install something, how a person wanted something designed. So if it was electrical, which is my background, we're going to have issue with drawings that have prints on them with symbols, with electrical symbols, which we will get into much later. We're going to have this whole in-depth discussion on a later video that just covers symbols and actual how to read a blueprint. Now today we call them prints because from the same term of blueprints, we just don't have blue anymore, and that we'll get into that later in this video. So basically what happens is now we have a installer such as us. We'll have the drawing with the symbols on it, and we will know exactly what those mean, and we will follow instruction by instruction exactly how to install this. So it could be anything from conduit installation. They could be wiring control circuits. Like say you're wiring a panel, you can go inside the panel and actually wire components. So typically in an electrical drawing, there's two different styles. You have your wiring diagram, which is a point to point. So it has devices laid out on your drawing, and the device would go from one device to the other with the wiring showing terminals connections. So someone can take a single piece of wire and connect it to terminal 32 and over here to terminal 14. And by knowing exactly where it begins and where it ends, they know how to hook up that circuit. Pretty well laid out. Another one is the ladder diagram. The ladder diagram is much easier to troubleshoot, but it's not as easy to install by. If you have a ladder diagram to go by, you're basically wiring where you think it should go. So some ladder diagrams will have the ability or the literature on there in order for you to have termination points and blocks and all that good stuff. Typically, a ladder, everybody knows what a ladder looks like. So you have your vertical rungs. Your vertical rungs is going to be your power source. On your left is going to be your power, your electricity, your 120 or 24 volts, your positive essentially, and your right is going to be your negative, is your neutral, your ground, your return, and in between there is rungs from horizontal lines, and those are going to be your circuits. So if you're looking at these things, they actually look like a ladder. You have two lines vertically, and then horizontal lines going across. Now these have to have things called conditions on them or components. And basically those are switches and different devices that would actually make and break a circuit. Now, if any electrical background or design, you have to understand that there is a flow of electricity. And we kind of went over this on the last one, but just a quick little overview. If you were to have let's say a flow of traffic on an interstate or a road, and you had a drawbridge in the path, all right? So if you open that drawbridge, the cars stop, right? You close the drawbridge, the cars will proceed to the destination. Electricity is pretty much the same thing. You're going to have a path, a flow, which is the traffic. You're going to have the bridge opening and closing, which is your switch, and then you have going from a source or a start point to a destination, and that's your circuit, and essentially. So by controlling this and knowing exactly where to put this circuit and how to actually energize components or devices such as motors, light bulbs, whatever, just by seeing that diagram, you're able to do exactly that, is wired up and make it very easy to for someone to wire, someone to actually sit there and make, be a installer of some sort. Even if you're an engineer and you're actually on the design side of this, they're very useful for troubleshooting too. You design this project, someone calls you up and says, hey, we're having a problem with such and such, device. You can pull your drawings up and look at them and say, hey, oh, there's our problem, and go from there. So now my background's all electrical. I'm going to let Mr. Guy take over for the but yes, the blueprint itself has been very fundamental in how things have been created over the last couple hundred years, as far as just the design aspect and how to really use the original drawing and to have a mass of people to be working on the same prints. So what's your thoughts on that, Mr. Guy?
Well, it's pretty neat on the chemicals used and what how they came up with the name, that chemical that they used. They use a similar process in screen printing. They use a photo emulsion solution to run over a screen and then they expose it to light with some sort of drawing or silhouette or whatever, and expose that to light. Everything that's not in the shadows kind of solidifies, and then you rinse the rest of the solution out, and then you screen print through it. So it's still that process is still kind of being used today with screen printing. So that's pretty neat. I didn't know that. So the wiring, or excuse me, the prints that you referred to are electrical prints. And those are very, like you said, very useful, especially if you're calling tech support or the original electrical engineer that designed whatever system that you're working on. There's other types of prints as well. And in my industry, I'm in the building trades and the HVAC and plumbing and that sort of thing. So what I deal with on a regular basis is an entire set of prints, and this is typically drawn up primarily by an architect. The architect will design the building, design the systems and the concepts as per the customer's requirements, and then he will subcontract out different portions of that. The architect doesn't know everything. He doesn't put it all together. He'll hire a structural engineer to engineer the base, foundations, footers, which may require rebar and that sort of thing, all the way up to basically the structure. Then we have a mechanical engineer, an electrical engineer to engineer those portions of things. So there's several times on a job site where you may have to deal, well, not the end user, the installer, people on site typically don't have to deal with architects and engineers. You typically go through the chain of command, the ladders, which I think we should probably get into in a later video, the hierarchy of a job site and who's in charge of what and how the whole system works, and RFIs and all that stuff. But anyway, this video is about blueprints, so we're going to just stick with that. I do want to say that the most blueprints, you start with the base building, right? And then again, I'm talking about buildings versus individual systems for like Joe was talking about. So and when you have a print in a light gray, you typically have the outline of the building or the floor plan layout, and then whatever print you're looking at, whether it's an electrical print, will show you circuit paths, perhaps sometimes. It'll show you definitely locations of switches, receptacles, whatever things that are going to be on the in the building. Same with the mechanical engineer or the mechanical prints. They're going to have whatever systems are going to piping and plumbing and ductwork and locations of each fixture, and then there's multiple floors. So sometimes when a piece of ductwork or something is going to maybe on one floor and it turns and goes vertical and then it goes into the next story, then you have to transfer, flip the page to the next one and continue on and see where that goes, because it might go up and then it might turn and go back the other way and then have a bunch of branch runs. So they're set up in layers, and I think in a future video we'll get into and actually show some prints. Right now you got to be careful with copyright infringements, and I didn't want to put anything on there that I wasn't sure was not free to put up for you guys to look at. So I'll seek out some individual prints for us to walk through. The other thing about prints is everything you need to know about that job is going to be on that print. So when you are talking about an entire building, there's going to be structural prints. There's going to be elevations, shows the facade of the building. It's going to show every square inch of that building and how it's to be put together. And you as a mechanical installer or an electrical installer or a plumbing, you have to go to those sections, and they're typically set up with a capital letter, like E100 will be the opening page to the electrical, and it'll give a brief overview. Flip the page over, the next page is going to give you a bunch of information, and you just keep going in. It might give you panel information. It'll give you circuits and fuses and what you're feeding and that sort of stuff. Mechanical's the same way. Plumbing's the same way. There's lots of information on there. Individual sections of a print is going to have a little number. Maybe it's a triangle, which signifies something somewhere on the print. Maybe it's an octagon or something, a square. So you have to just use the keys to read every section of that print, and it will tell you and call out for exactly what you're needing to do there. So back to the mass production of how Joe was saying these things are put together, and the old school method, which was a little labor intensive, it's gotten a lot easier now, and it's kind of a cut and paste world, if you will. And in a second, Joe's going to get into that part of it. But the only other thing I think I could say about sometimes prints, I have some side notes here that I'm looking at, is that when an architect is putting all this information together, that's a lot of information. And he's looking at a two-dimensional drawing of what needs to go on. And in some cases, plumbing, mechanical, and electrical systems have to be all installed in a ceiling that's only gives you 2 foot to cram all of that stuff in there. And sometimes things are run right into each other. So that's where knowing what the hierarchy of the job site is, you can get with your supervisor, your project superintendent. Maybe you're dealing straight with a project manager. Maybe the engineer is right on site. Hard to say. All job sites are different, but you have to put in an RFI, a request for information. And in some cases, you have to have a drawing, or you have to get a deviation approved to get something altered, because most architects want that to be installed exactly how they drew it. That's what the customer approved, and that's what they expect. So if anything deviates from the initial drawing, you have to get that in writing. Again, I think I'm going to get into hierarchies of job sites and that systematic approach, how you get things done on a job site, and how all of that works. It can be mind-boggling sometimes, and headache as well. But Joe, where's technology brought us into these prints and how we use them out in the site, and how are they produced now?
Well, now the prints are actually, they're more of a CAD drawing, computer aided drawing, and that's more of a layered, I guess, design. So before, everything was two dimensional. Everything was just a piece of paper with a single layer, a single phase of drawing. So the CAD environment allowed it to be digital at this point here. So you like to have layers of things on top of each other. So enable was to work on top of each other, so your structural people are building your building, your background, the backbone of the structure. Then your heating and air and ventilation people come in, and they come in and do all their stuff, and they hook up all their duct work, their fans, and all that good stuff. Plumbers come in, they do their stuff, and these drawings allow you to have everything built in a layer where you could actually have a pretty, it's supposed to be, it never usually goes smoothly, but a pretty smooth transition between trades. And then you have just even on the electrical side, usually electrical was one of the last ones to always come in. They are the ones that are going to bring in the power source for the building and your supply circuits. And then there's another trade, which is the control voltage trade, which is your alarm system, your audio video systems, so like that. We have a user that was commenting, Curious Yellow Solar, that was, and they're mentioning that they are also do low voltage equipment, and that's a big field as well. And it's just as important because the drawings, especially in that field, has to be so precise, because you're talking milliamps of problems you could have to blow your system out. And everything has to be perfect. Everything has to be right on. I mean, there's room for error, but for the most part, everything has to be pretty dead on as far as the drawings and everything goes. But yeah, today everything else is before was again a blue background or a gray background with a white or off color prints. And that was pretty much what you had. And now it can be anything. Typically now it's a white paper with black drawings, or blue paper, or there's so many different variations of drawings anymore. Something else that you were elaborating on a few minutes ago was the nomenclature, the actual writing, the descriptions of where wires go and what the wires are for. So there's different levels of this as far as the information that is passed from the engineer to the installer. The key, which is usually in the corner or the beginning of the drawings, is the key, is the part that actually makes it possible for you to understand what they're trying to say. This could be anything from the symbols, what the symbols actually mean that they're using. This could be variations of equipment, voltage levels. I mean, whatever. The key of the drawing tells you exactly what all these symbols are describing. Another thing is the wire numbers and the page numbers are very important for modern drawings. So typically a destination or a wire will have a number assigned to it. That number is broken down into groups. So it can be a machine code that is part of that number. It can be also a component of that machine. It can also be a subcomponent of that machine, all the way down to the terminal and then the wire number itself. So you could have an 8-digit number, each section of that number meaning something. It's usually also part of that number is also a page number reference. So exactly if a wire was to end mid-page, mid-print, and stop, and it has a note or a dot on the end with a number, pretty much what page to go to follow on and continue on with that drawing. So it's pretty important to, once you get a drawing in your hands, is to establish communication with the engineer with using that key, knowing exactly what they mean, how they mean it, what they're trying to say to you, because that's really the only contact they might have with you is a set of prints. So understanding that and really getting into the detail of the prints is very important. Also the the symbols itself, they're so numerous. I mean, there's so many of them. There's no possible way we could go through them all. But there's many places online you can find that. But for the most part, you can actually look at a lot of the diagrams and have a good idea of what they mean. There's pretty generic ones across the fields, but there's specialized ones, especially low voltage and electrical and hydraulic, and each of them have their own fields. So just understanding that how it looks, the look of the page, what the information on the page means, and pretty much how the what the engineer is trying to give you information wise, and to pass that on. So, anything else you got for us?
Yeah, I'm going to elaborate just on a couple things you said. First, I'd like to say that it's obvious and it's apparent that there are multiple different prints in industry and building trades and things of that sort. So my background is the building trades. So it starts with concrete, erects a building, all the mechanical systems are installed. And like Joe indicated, he said electrical usually is the last to come in, and he's right. This is why, excuse me, when you're installing all of these mechanical systems, it is a lot easier to reroute a half-inch conduit, or for that matter, an Ethernet wire or a smoke detector wire around a 3-foot piece of ductwork. So typically installation starts with the largest items first, and they work down to the smallest items because the smaller one's much easier. Sometimes mechanical and plumbing have an issue because pipes have to be, they have to have pitch, and I've been in situations where I've had to run ductwork just up and over a waistline that couldn't be run anywhere else. If it was ran anywhere else, it'd be below the ceiling, and so that's some of those things I was talking about. They run into each other, but yes, they start with the largest and work down to the smallest. And so that after the building is built, then you get into, and we're going to, say it's a shop, it's an industrial setting. And after the shell of the building's built and all the mechanical systems are installed, and now we're talking about implementing and installing the machinery. So the millwrights will come in and they're following prints too. They've got prints of all the placement of all of these pieces of machinery, and you'll have welders come in and weld everything up and get all of that put together, and mechanics that'll get all of the machinery set where it needs to be, and then the electricians will come in and wire those systems up. And these are those, and some of these machines, they're bigger than a house. Some of these machines could be as big as a store. So, no, like Joe was saying, is that the prints that you're looking at are going to have indicators on the wires. They're going to have a location, because it's not just going to be a couple of pages worth of drawings. It's going to be page after page after page, and it would be almost impossible without these identifying numbers and locations on them to know where to find everything. So there's prints for darn near anything, and then that's being built anymore. Everything's designed and then sent out to have built. So whether it's building trades, industry, things like that, there's lots of that. I was going to suggest, and tell me what you think about this, Joe. You had mentioned symbols. Symbols are quite, like you said, there's a lot of them, and nobody's going to know every single one. But I thought maybe we could provide, or not right now, but we could put together some PDFs for different trades and start with the most common symbols as we get into more in-depth content. Say if we're talking about an electrical system that you're presenting, you could also put together a PDF that would follow along with that, so that everybody could understand and follow along with what they're doing. Along with the same thing, if I'm doing an HVAC or mechanical system, there would be an associated PDF with the symbols and things like that. But I think that we could probably offer that in some of our extra content that we've been talking about putting together as well. So, what's your thoughts about that?
Yeah, I agree. We can throw something down that is a quick reference for people to at least understand what the symbols mean and what the drawings are doing. A lot of stuff is proprietary, and just means that they just have to we just get approval for reposting those. But yeah, I think majority of our stuff we could easily have at least a cheat sheet for people that are interested in knowing more about this stuff. Throw together some symbols or some pages of symbols that would at least help you get through the basic diagrams. And just to kind of to continue and kind of close what we're talking about here is understand the drawings and having that aspect of your career is very important, because when you put on a job, even as a helper or just a grunt worker, a person just pulling the pipe or whatever, you're going to have that prints in front of you. You're going to have to understand what those things mean in order to do your job properly. And if you get more advanced into your career and become more of a design or engineer aspect, you're obviously going to need to know more about prints. So prints is very, very important to understand. And I think this is something we can definitely elaborate on further later on.
Absolutely. There's so much to get into that we couldn't cover it in this. It's just a brief overview and to kind of understand prints and all of that. And it was awesome about at the very beginning of the video how you brought the history into that. It's a lot of information in there that I didn't know about blueprints. I was thinking about when I was in school, the old Ditto machine, as you were talking about the mass producing that. So. But yeah, so again, everybody, don't forget to subscribe and leave a comment below, because your comments is what steers our content, and that's what's going to help us in the future bring you exactly what you guys are looking for. So don't forget to check out the website, and I'm saying this now, it's not quite built yet, but encompassingselfreliance.com, encompassinghvac.com. Facebook pages associated with the exact same name for both as well. And Joe is still working on getting his internet presence put together. And once it's out there available, we will present that to you as well. So I will thank you once more for joining us for another video. And do want to say that our next video, our next live event video, which will be next week sometime, we're not set up on a schedule yet. We're still trying to figure out what works best for both of our busy schedules. But next week's live event is going to be wiring schematics. We are going to start with basics and move on from there. And yeah, so Joe, any last words?
No, like you said, just make sure everybody comments and gives us some ideas of what direction to go into with the broadcast, as well as just just a basic feedback would be nice for everybody. Also, just to close up here is I really always appreciate the feedback and the participation. We've had a couple people comment, and it's nice to get feedback as we go through this. So to keep it coming, and we'll definitely catch you next week.
All right, we're going to sign off. Thank you, everybody, for joining us for another live event, and we'll see you on the next one.